All right, if you've ever stopped and wondered how words actually bind together to form complex, coherent thoughts instead of just, being a random jumble of noise, then you are in the exact right place. Today, we're diving into an incredibly elegant framework from Michael Halliday and Rakaya Hassan. And what's so cool about this is that it treats systemic functional linguistics like the literal physics of language. We aren't just looking at grammar here, we're analyzing the invisible gravitational forces that hold a text together. I mean, just listen to this brilliant opening assertion. It completely redefines our entire task. We aren't here to subjectively interpret art or guess at a writer's hidden feelings. Actually, scratch that. It's more like we're stepping out of an art appreciation class and walking right into an engineering lab. We are here to objectively map the structural vectors of meaning. We want to know the mechanics of exactly how a text works.
So, here is our roadmap for this explainer. We'll start with the architecture of cohesion, break down the anatomy of a tie, map cohesive distance, walk through the universal coding scheme, and then finally, we'll decode a text's DNA.
Section 1. The architecture of cohesion, beyond the sentence.
Okay, so what actually makes a text cohesive? Well, it relies on these invisible structural forces called presuppositions. And the basic atomic unit of this entire architecture is what we call a tie. You can visualize a tie as a glowing, directional tether connecting two points of meaning. For example, it links a cohesive element, let's say the word she, directly back to its presupposed element, which might be the name Alice from 3 lines ago. Without that tie, the word she is just floating completely meaningless in space.
Let's move to Section 2, Anatomy of a Tie, Vectors of Meaning.
Notice how these cohesive tethers actually have geometric directionality to them. Think of them as literal arrows of meaning. Now, occasionally a tie can be cataphoric, which means it points forward into the future text to resolve its meaning. Like when someone says, "Here is the news," before actually delivering the news. But for sure, the most natural and common vector is anaphoric. An anaphoric tie points backward to something we've already established. It mirrors how human memory works, right? Just building layer by layer upon what's already been said.
Section 3. Mapping cohesive distance, the topography of ties.
So, how do we measure the distance of these ties? Well, we don't measure them in inches or even by word count. We measure distance purely by the number of intervening sentences. It's a topological map. An immediate tie happens right next door in the very adjacent sentence. But if the meaning has to skip over sentences that have absolutely nothing to do with it, we call that a remote tie. And if the meaning gets passed along from sentence to sentence, kind of like a baton in a relay race, that creates what we call a mediated tie. This is brilliantly illustrated using an example right out of our source material. Imagine you're reading a passage from Alice in Wonderland. In step 1, sentence 5 uses the pronoun she. But where does that point? Well, in step 2, sentence 4 also just says she, so it mediates the tie. It pushes us even further back. Finally, in step 3, we hit sentence 3, where the actual word Alice appears. We're tracing this pronoun across multiple sentence nodes until we finally resolve that presupposition. It's literally a chain of meaning. To formalize all of this, linguists rely on something called the index of distance. And the absolutely crucial thing to remember here is that this framework strictly counts the number of intervening sentences to establish a precise numerical index. It doesn't matter if the target word pops up once or half a dozen times in that resolution sentence. The only metric we care about is the structural distance across the text itself.
Section 4. The universal coding scheme, the multidimensional matrix.
This taxonomy right here, this is the absolute heart of the system. It divides every single cohesive tie into 5 distinct categories. You have R for reference, which covers things like pronouns, S for substitution, where a placeholder swaps in, E for ellipsis, which is super interesting. It's a structural omission, literally a silence that requires context to be understood. Then C for conjunction, which dictates the logical flow, and finally L for lexical cohesion, which relies on related vocabulary. Every single connection in a text falls somewhere into this matrix. But knowing just the type of tie isn't quite enough, is it? We also need to map its exact geometry. By combining our primary category letters with this alphanumeric syntax for distance and direction, we generate a precise mathematical coordinate for any cohesive bond. A 0 means immediate, M stands for mediated, and you bracket the number of mediating sentences. N is for remote non-mediating distances, and K flags those rare cataphoric, forward-pointing ties. It's essentially algebraic notation for grammar, which is just incredibly cool. Section 5. Decoding a text's DNA, the matrix applied.
Okay, let's ground this high-level theory. Let's run a real, everyday literary artifact right through our matrix. When we completely disassemble a snippet of Alice in Wonderland, mapping the sentence numbers against the cohesive items, the matrix calculates the exact type, like R12.6, along with the distance and presupposed item for every single tie. What looks to the naked eye like a simple children's story is instantly revealed to be this densely woven, interlocking web of structural vectors.
Now, you might be sitting there wondering, why go through all this effort, right? Why does this rigorous mapping actually matter? It matters because it unlocks a fundamentally deeper understanding of human communication. It allows for advanced stylistic studies. You can literally calculate if an author leans heavily on lexical ties versus conjunctions. But even more crucially, this exact kind of systematic logic is foundational for natural language processing. It is exactly how we teach computers to understand that a pronoun in sentence 10 relates to a subject from sentence 1. It objectively explains why a text functions successfully.
So as we wrap up this explainer, I want to leave you with a final thought to chew on. How are the invisible geometric webs of meaning holding your own daily conversations together? Seriously, the next time you're talking with a friend or even just reading an email, try to visualize those overlapping, anaphoric vectors of meaning. Picture those tethers flying back and forth, holding our shared reality perfectly intact. Language isn't just words on a page. It is a profound structural marvel. Thanks for joining me on this deep dive.